So what we dealt with in the last class was descriptive statistics. Okay, so last class what we dealt was with descriptive statistics. Hope you are clear with the types of variables and the descriptive statistics. So here we go. We dealt with types of variables, discrete, continuous, categorical, ordinal, and dummy variables. Okay, and we also dealt with types of descriptive statistics. We've seen what is mean, median, mode. One second, guys. Okay, can you guys see my screen? Krishna or Santosh, if somebody can confirm.
No.
Hey, Santosh. Okay. Krishna has confirmed that he can view the screen. So here, these are the types of descriptive statistics which we have seen. We have seen count, we have seen percentages, we have seen mean, median, mode, we have seen range, variation, standard deviation. What we did not see is the percentiles and quartile ranks. Okay, so percentile, let's not get by the book definition here. To make it very simple and clear, percentile is basically a way of ranking. So, so if you stand at the 90th percentile, for example, 90th percentile means 90 percentage of the data values are below that and 10 percentage of the data values are above that. So usually in exams, I mean in competitive exams, they do not give ranks, they give percentiles. So for example, in CAT, if the score, if the exam is for say 150 points and the highest score was say 73, then that 73 becomes the 100th percentile. Okay, so that is how percentiles are. If if the next score, the top score was 73, the first one scored 73, and if the second person's score is say 50, this guy becomes 99.99 percentile. It is irrespective of the amount of score or the points you have received. It's just the order in which you're receiving. Uh, See, it goes like this. Okay. Okay. So the total score, points, the exam was for 100, and the first one scored 73. He becomes the 100th percentile. Okay. And if the second one scored 52, this becomes 99.99 percentile. Did you guys understand? It's a very tricky concept, but that is how it is. For the 100 percentile means there is nobody above this guy and everybody else is below this guy. For the 99.99 percentile means there is only one person above this guy. Everybody else are below this particular score. So that's the percentile. Hope you guys have understood. Moving on to quartiles. Quartiles is basically, it divides data into four quadrants. equal number of data points are distributed into each quadrant. So if this is the line which we have, so it says this is quadrant 1, this is Q1, Q2, Q3 and Q4. This is Q2, Q3 and Q4. That is how it divides. This point becomes the exact midway between these two quadrants. So if you guys remember from our last class, which point lies between the data points? We have discussed this in the last class. This is the median. Okay, so basically quartiles are the data points are divided equally into each quadrants, and the midway is the median. So these are quadrants. So that is percentiles and quartiles. Uh, I don't think you will use percentiles and quartiles to a great extent, but it is good to have information, because most of the times if somebody is presenting something and they are saying percentiles and quartiles, you should know what they're talking about and where data is residing. So is it clear, guys?
Yes, sir. Yes, sir.
Okay. So let's move ahead. So we have seen how to calculate the descriptive statistics using Excel. So had you had a chance to try any of these with some sample data? Santosh or Krishna, any of you tried?
Yes, sir. Try, but just I love
There is a lot of
visualization.
disturbance. I just cannot understand anything. Krishna, there is a lot of disturbance. Can you type on the chat window? Okay, Krishna is typing. Uh, so I thought I will introduce R to you guys today. So we will see how to load data into R, how to manipulate data in R, and how to get the descriptive statistics from R. So we will be using the same data which we used uh, for understanding the descriptive statistics through Excel. So here we go. So R is pretty much simple. What I am showing you here, this is R Studio. This is called R Studio. R Studio is a good interface. This interface looks good, but when actually you download R, this is what you will see. This is the interface which you will see. So so it's a free open source, so you can go ahead and download it. It is pretty much an installable Excel file. Just download, double click on the exe file which gets downloaded, and execute it. You will be able to download install R. After you download and install R, search for something called R Studio. Then that is where this is basically like an interface. For example, if somebody has programming language, then this is like an Eclipse kind of a thing for Java. So this is kind of an easy to use interface. So this is R. Okay. So have you guys used R anytime, or this is the first time you're even looking at it? Krishna and Santosh. No. Okay. So but it is pretty much simple. You can go ahead and Google it. You will be able to download it pretty much very easily. Uh, so this particular window, so this window is where you type your code. This is where you type it, and this is the window which is called the console here. This is where you see the output of whatever you're executing from here. These are the see, in Excel you have data in your Excel spreadsheet. When you load that data into R, that becomes a data frame. That is called a data frame. So whatever data you have, it will be listed here. Okay. So for example, R can be used for simple calculations here. See, I have just written 1 plus 1 and I am executing it. To execute this statement, here you have a run button. You just have to click on that. You see 1 plus 1 is equals to 2. So this is how you will get the results. So you can do anything, any kind of a calculation you want to do here. You can do multiplication, you can do division, anything. Okay. So let me try and load some data into R. So I'm using a CSV file, comma separated file, in order to load data. If you guys want to look at what do we have in the CSV file. Okay, see, this is the data. If you remember, this is the data which we had. The employee salary, age, and qualification. This is exactly the same data which we're loading into R. So since we have a CSV file, this is the command for R to load the data, read.csv, and within brackets you will have to give the location of the file. So if you see, this is the location of the file, including the file name, employee.csv. You just have to keep your cursor on this particular line and execute it. See, employee, this has now been executed. If you want to see the data, see, this is called a data frame. We now have data in this particular employee data, which is called an object also. So if you want to see if our data is loaded completely, now you just have to type that name and then execute it. See, if you see, we now have the data on the screen. So we have employee name, we have salary, age, qualification, which this data has now been loaded. This data is now available in R for whatever we want to do. Okay. And if I want to access a specific column, not the complete date, then I can do it using see, uh, it will automatically pop up the data frames which are available. So employee data is the data which we have loaded. Select that, and then you use a dollar sign to reference a specific column. See, we have employee name, salary, age, and qualification. If I want to look at employee name, then I will do as employee name and I will execute again. See, it will now list only the employee names here. In the same way, if I want to list salaries, employee data, dollar,
Yes.
yeah.
Yeah, they're accessing complete data in R and accessing a specific variable. These are we have to write something inbuilt things.
No, no, you don't have to write. This is all available in R.
Or what we call it actually.
What?
What we call it means it's a variables or something method slash accessing a specific variable.
It's a method which is already implemented.
Okay,
You're
inbuilt
just
method.
calling it. Yeah, it is an inbuilt method.
Okay, yeah.
Yeah. So this is how you access them. See, if you remember, if you're a programmer, then you put a dot. So here you put a dollar sign to access it. Okay. So this is how you access them. And if you want summary statistics for, say, salary, so this is the function here. Summary is the function which is already been inbuilt. We are just calling that function and passing the variable for which we want the summary statistics. So you put a summary there, and within the brackets, employee data dollar salary, and then you run it. See here, you have the minimum. It has given you the minimum number. Minimum salary was 22,840. The first quartile is 39740. It means anything which is less than this falls in the first quartile. And we have the median here. Median is also the second quartile, so it is a midpoint. So anything which falls which is less than median and greater than the first quartile number falls in the second quartile. So basically it looks like this. If we go back to the PPT and see. So basically, okay. So basically, if this is the line and this is the Q1, this is Q2, which is also the median. This is Q3. Okay, this becomes Q4 part. So what we are talking here is 39740. 39740. So anything which is less than this is the first quartile. So any salary, any person's salary less than this falls in the first quartile. So we said median is 54210. So this particular point is 54210. So anything which is greater than 39740 and less than 54210 falls in the quartile 2, this part. And third is 70950. This is 70950. So anything which is greater than 54210 and less than 70950 falls in the third quartile. Anything greater than 70950 falls in the fourth quartile. So that is how you will have to read these numbers. Okay. Then it also gives you the mean and it also gives you the max. So this is the summary statistics in using R. So it is pretty simple. So if, see here I have referenced it using a dollar sign, so I'm getting data only for salary. If I don't do a dollar, if I don't use a salary, I just pass the complete data frame. So summary and then complete data frame and then I run it. Here you see it will give you the summary statistics for all the variables which are there. Okay. So you see for salary it gives you minimum, first quartile, median, mean, third quartile and max. In the same way it will give you for age also. And if you see for qualification, what was the data which we have? We have BCom, BSc, BTech. So what did it give us? It gives us the counts. So based on the data, it gives us the counts. So, and for employee also it is giving us the count. So if you see employee 1 is only 1, right? So we don't have multiple employees. So employee 10 is 1. So it is giving us counts. So uh, so if you remember how is data loaded here, let's do this. Okay, so str is a command which will describe the data for you. Okay, it says there are 26 objects and there are 4 variables. So we have 4 variables. One is employee name, salary, age and qualification, and we have 26 columns in that. If you see employee name is a factor, in R factor means a categorical variable. So it has 26 levels. I mean, so it says there are 26 different names given. And salary, it is taken it as an integer. Age, it has taken it as an integer. Qualification, again, it has taken it as a factor, and which has 5 levels. So we have BCom, BSc, BTech, MTech, and MBA. So these are categorical variables are called are represented as factors in R. So str is the command using which you can actually look at what kind of data do we have. Okay, and so we've seen summary statistics. Okay, in the summary statistics, if I execute this command, say, see, this we are able to execute, we got the output. This we are able to execute, we got the output. If I execute this particular line, it is throwing us an error. So the only difference is I have an S capital here. So if I make this as a small and then run it again, it executes. So this means R is case sensitive. So so you will have to remember that. Okay. And packages in R. Okay, this is a very interesting topic. So are you guys clear till here, Santosh and Krishna?
Yeah, yes, I have understood.
Okay, perfect. So packages in R. Uh, Santosh and Krishna, do you guys have programming background, and are you from programming background, or you do not have any programming skills?
Yeah, myself is I am automation engineer and selling with Java, so I can understand.
Okay, perfect. Santosh is a DB guy, right?
No, sir. I don't have. No, I
Oh,
don't have idea.
but are you able to follow through what I'm trying to tell you?
Yeah.
Okay, perfect.
But okay.
Yeah, I will share this particular file with you. Please go ahead and download R and then uh, uh, do practice. I think it's pretty easy. I mean, these are the lines of codes which you will have to do. Uh, what you will have to do is you don't have to try and remember summary, str, and so on and so forth. You will have to know what you want, and then you just have to Google it. See, for example, uh, if you do a simple Google, let's do a simple Google search here. How to get summary stat. See, if you see, I did not even type it full. How to get summary statistics in R is the first one, and then you just go there. You will get the how to get it. You just have to see. You have it here. You just have to. You should know what you want. Go ahead and search it. You'll get it. See, he has also clearly written you'll get mean, median, 25th, 75th quartiles, minimum and maximum. Okay, so don't have to worry about trying to remember, and nobody will ask you what is the code to get summary statistics in R. Nobody will ask you in any interviews. If they are asking you these questions, please walk out of that interview. It is not worth joining that particular job also. Okay, only for the sake of asking, they're going to ask you, but ideally nobody will question your R skills. Okay, everybody is interested in what is the background knowledge you have rather than what code do you remember. It is pretty much not useful to remember these things. You just have to go ahead and then Google them. Most of the times, if I did not use the summary statistic code over the last 2 3 months, then I also tend to forget, and then I will have to refer back, or again I will also do Google and then get, oh yeah, summary is the line which I will have to use that to get summary statistics. So it does happen like that. So moving on, uh, R has something called packages. Okay, this is something which you will have to remember and very important. Packages. So for any of the program which we want to run on our data, any advanced statistics like linear regression or any of the uh, artificial intelligence related code or machine learning code which we want to run, we will have everything. We do not implement them. See, neural networks or say linear regression has been invented by somebody long back, very long back. But we do not write that code in R. That code is already available in R. We just have to install that particular package. So we install those packages and then we use them and we call functions or methods from those packages and run it on our data. For example, do you guys remember what dummy variables are? Yeah, Santosh and Krishna. Dummy variables. What happened, guys? Don't remember dummy
Yeah,
variables?
yes or no answers that, like
Yes, perfect.
true or false.
Yeah. So true or false kinds of a thing. So dummy variables. So categorical variables need to be converted into dummy variables in order to run any program on them. So so let's go back to the earlier. So yeah, these are dummy variables. So name and car, person one, person two, person three. They has a Wagner, Swift, Alto. These are categorical variables. If this is converted to a data frame like this, it becomes dummy variables. So how do we convert that in our? We don't have to write any code for that. Somebody has already written the code for us. We just have to install that package and then call the functions. So install.packages.dummies. So install.packages is the function which installs the packages, and dummies is the name of the name of the package. So if I run this, one or more packages have been updated. So since I already have it installed, it is asking me, do you want to update it again? So I would say no, but you guys go ahead and then try and install it. So once you have installed it, this is a one-time job. You don't have to install it every time you do it. Okay, this is just a one-time job. So what you do, okay, it is still installing. Okay, after that, if tomorrow you have closed your R session and you're coming back tomorrow, you just have to see what happens is you will have to invoke that particular package. So it is available for R. If you have installed it and then you've installed it means that particular package is there in your system now, but to R it is still not available. To make it available to R, you will have to write this particular line item, which is library.dummies, and then you have to execute it. Okay, if you execute this means that particular library is now available for R, and now I am converting. So this is the line item. This is the kind of code which you will have to use to convert your categorical variables into dummy variables. So if I run this now, and then I will execute this particular data frame. You see, if I go to the top, you see, employee is also been converted into dummy variables. But is it correct to convert employees into dummy variables? See, employee 1, employee 10, this is the name which it has given to each and every variable, employee 11, employee 12. So we don't want this to happen, right? This is absolutely wrong. We don't want that. So what we will do is we will reference the column name which we want to convert. So it's just the qualification which we want to convert, and then if I run it again and then I execute again. Okay, something's wrong. Okay, let me check that and then I will get back to you how to convert a single variable. Let me not waste time on trying to research it now. Okay, let's try something like this. Okay, did you guys understand how to convert into dummies? Packages and libraries in R? Santosh and Krishna?
Can you explain that? Library dummies.
Okay, sure. So R has something called packages. Okay, so if I want to run any of the advanced statistics in R, anything, say linear regression or any artificial intelligence related kind of a code wherein neural networks, support vector machines, or clustering, cluster analysis, decision trees, everything we will not implement or we will not invent them. This code is already available. Somebody has written that and then they have stored it as a package. What we will have to do is we just have to install that package, and we just have to use those functions, call those functions in order to use them. Okay. So in the same way, as I have told you, categorical variables need to be converted into dummy variables. But how do we do it? So there is a package called dummies in which somebody has written the code to convert it already. So what we will first do is we will install this package called dummies. After that, we will invoke it. Invoking means making the package actually active. You installed it, it is there on your system, but it is inactive. But now, using this particular call, I will activate the function. And after I have activated the function, I can use my code to convert my categorical variables to dummy variables. But if you really want help here, now let's look at another part of R. So you have help here, you have packages here. Go to the packages and search for dummies here. Okay, so this is there. I just have clicked on that, and you can go back to Google again. Dummies package in R. Usually the first search is always a PDF. Okay, and we are also interested in the first one. Just click on that. So the person who has actually written this package, who has actually written the complete code, he must have written in, say, Java or whatever. So what he did is he has documented whatever he did. So the last update was in February 2015, and the name of the person who has written this particular package is Christopher Brown. So if you come down, he will give you everything. What are all the functions which are available? Okay, how to convert. See, he has written usage, how to usage. See, dummy.data.frame data, and then you omit constants is true. What is omit constants is true. If you see arguments here, if you come down, he must have explained everything here. Okay, so you just have to go ahead and read them and try to understand them. It is not possible for me to take you through each and every comment and then try and explain and make you understand what this means. I would really suggest go ahead and then try reading something or doing something. If you still have a problem, please shoot an email and then I can reply back onto you, because if we start exploring each and every package in R, it would be like we can do that for 2 years, every day 2 hours. So that's not possible. So it would be on your part to try and research. I am here to help you, to guide you and then make you understand. But this is how you will have to do it. Each and every package is very clearly, precisely documented. You will have to search for that package in Google and then you will get it. It's usually a PDF document. Okay. Uh, I know it's a little difficult. It's a little hard for Santosh. I know Krishna, it could be very easy for you. But Santosh, do you want me to take you through all this stuff in R again, or are you fine? Do you want to try and then get back?
Yeah, I will try. Sir.
Okay. I will also share this code. Okay. It is pretty easy. I mean, initially it could be sounding very complicated for you, but this is pretty easy. This is maximum, this is the amount of code which you will write. Nothing more than this. Absolutely. Even if you're running an artificial intelligence kind of an algorithm, the amount of code you will write is maximum one, two, or three lines, nothing more than that. Okay. So let's get back to presentation. So we did descriptive statistics using Excel, and we did introducing introduction to R, we did loading data to R, and then we did how to get descriptive statistics in R. Okay. Let's see what a histogram is. So histograms is a specific way of representation of data in statistics. So how do we generate histograms? If you remember, we did, it's the same data again, the employee data. We are going to use the same employee data. But what I did this time is I took frequency. So sorry, we are not using the employee data. We are using the packed weight data. If you remember, we said packet 1 has 96 kgs, packet 2 has 98 kgs. So this is the data which we are using. So we count. So this is basically frequency. So I am counting how many in the total packets which we have. How many packets do we have? 254. Yeah, in the 254 packets which we have, I am counting how many packets have 96 kgs, how many have 97, and so on and so forth, how many has 104 kgs. So I'm doing this count. Okay, this count is what we have here. Yeah, here. So I have 24 packets which are 96 kgs. I have 25 packets which are 97, so on and so forth. I have 30 packets which are 104. Well, after that, what I'm doing is this is bin. After that, I'll just go select my data. I'll go to insert. I'll choose a bar graph. I'll say okay for this. So whatever I get, this is a histogram. Okay. This is how histograms are plotted. So histograms are basically frequencies. Histograms can be plotted for anything. For example, if I want to plot a histogram for this, BCom, BSc, BTech, MBA, and MTech. So what do? In my employee data, I will count how many BComs are there, how many BScs are there. And then again, I'll select that data and then go to insert and select this particular bar graph. And this is a histogram again. Okay. So why is it important to study histograms in the first case? What does this represent? So histograms are frequencies, are bar graphs related to frequencies. Okay. So it is important to study to learn about how the data is distributed. Okay. See if here we have an order. I mean we 96, 97, 98. So usually histograms are always ordered and then plotted. Okay. Here, since it is BCom, BSc, BTech, and MBA, it really does not make a lot of sense. It does not make a lot of sense to have histograms for categorical variables. So these are categorical variables, right? So it does not make sense. It is a simple bar graph. But wherever we have continuous variables, say 96 kgs, 97, 98, we'll plot a histogram. Histogram will give us information about how data is distributed. So now we are talking about data distribution. Okay, what does data distribution means? See, any for any kind of a data, if I can mathematically write down an equation, mathematical equation, okay, then that particular representation of the data is called how a data is distributed. I'll make it very simple again. See, if we go back to our Excel where we have the data, okay, raw data. So this is the data which we have. So employee 1 has a salary of this and his age is 34 and his qualification is BCom. If we forget about the categorical variable, we are now only talking about say employee and salary. Okay, we now have employee and salary. If I can mathematically write down, if say if for example, yeah, so for example, this is y. If this represents my y, okay. If I can write down some equation, which is say x1 plus x2 plus 5x plus 10y 10z, anything of this kind. If I can represent my salary y in terms of any kind of an equation, then that particular equation represents the distribution of the data. We will not never try to find out this equation, but you will have to know that any data can be represented in the form of an equation. If you remember from your schooling, we always studied about calculus. So calculus was always about trying to find out that equation which represents your data. So yes, it is possible, but we will not do it. It is not required. But you will have to know that any data can be represented in the form of an equation. That form of an equation is important to study how the data is distributed. Okay. uh, so usually your data is always distributed in this format. You will have a tail. You will have two tails. This is called a tail. This is another tail, and this is called a peak point. Okay. So this is called a unimodal distribution. So since we only have one peak, if we go back to our own example, if you see, we also have only one peak here, no? Okay. So we also have only one peak here, no? So our data starts like this, moves like this, and ends like this. So we have one peak here, no? This is one peak, this is one tail, this is the left tail, and this is the right tail. Okay, this is the right tail. So this is a unimodal distribution since we only have one peak. What distribution is it now? Now, okay, we know that this is a unimodal distribution, and we know there is only one peak, and we know this data can be represented as an equation. But there are like close to 50 or 60 kinds of equations which are available, but most of and most of your data fits into these any of these 50 or 60 kinds of equations. But what is that equation into which our data fits in? It is important to find that out, very important to find that out. And how do we do it? We never do it. I mean, we will never try to find out into which distribution our data fits into. In every statistical analysis which we do, we will always assume that our data is normally distributed. There is one distribution called normal distribution, and this is one assumption which we will always do, that my data is normally distributed. We will not even try and research into what exact distribution it falls into. We will not. We will happily assume that it is normally distributed. And uh, guys, are you able to follow what I'm trying to tell you? Histograms, basically we will calculate frequencies and plot a bar graph, which is called a histogram. And currently, whatever we are able to see on the screen, that's a histogram for our weights data. And if you try and draw a line, this is how it will look like. This is a unimodal distribution which has only one peak. There is a bimodal distribution also. This is how the data will be. This will have two peaks. Okay, but in our data, we only have one peak. And what is a distribution? Distribution is a way of representing your data in a form of a mathematical equation. We will never try to find out that equation. It is not required because we will blindly assume that all our data is normally distributed. Yep. Santosh and Krishna, you want to ask any questions here?
Yeah, I'm getting. And if you see in the, I mean, health related some, how can we calculate the number of distributions it will come?
I'm sorry, I did not get that. Health related?
Means some of the graphs is coming heartbeated graphs,
Okay.
up and down, look like that. Then the peak.
Oh, you're talking about if you take an ECG,
Yes, sir.
yeah, okay. Oh, no, that is not a histogram again. Okay, see, the way ECG works is, uh, okay, ECG, what happens is you will have like three different, this is a lower limit line, this is an upper limit line, and this is the baseline on which the ECG report basically generates. So what happens is this is how you will get it, right? And the doctor is actually interested in these points. See, this is the lower threshold, this is the upper threshold. So he's interested if your heartbeat at any point of time is crossing this line, uh, is going above this line or coming below this line. So he's interested in these points. So that is how it will look. So that is how your ECG looks like. So it is not related to your histograms at all. So it is your
Okay.
heartbeat or whatever percentage they are calculating, I'm not sure, at this particular minute. So if this graph is for say if the EC, this is for say 1 minute, every second they will looking at what is the count, what is the count, what is the count. So this say probably this is the 50th second, 50th second it is crossed, means okay, there is something happening, there is a real problem in the heart. If it is coming below that, then your heart is really not functioning. That is how they define it, and that is how they find out. But it is not a histogram.
Okay. Thank
Okay. Yeah. Santosh?
Okay, sir.
Okay, perfect. Okay, now the interesting part is I've told you we will happily assume everything is normally distributed, right? So what does a normal distribution means? Very simple, absolutely simple way to remember is once you have drawn your histograms, you have calculated frequencies, you did everything, okay, and you have drawn your histograms. A normal distribution means this point is your mean, median, and mode. Your mean, median, mode all lie at the same point. It means you are normally distributed. For example, you have data points 1, 2, 3, 4, 5, and 6, and say these are all, say let's take a very simple example. Okay, I'm taking 10. All of these have 10 value only, and then we have 7 data points. All of these are 10, 10, 10, 10, 10, 10. So for this, if you take the average, so let's make it 8, 9, 10, and 10, 10, 10. So what's the average of this? See, addition is, you will get 100. 100 divided by 10 is 10. So mean is 10. Mode is also 10 because 10 is the repeated, right? Most number of times 10 is repeated 10 times, so it is also 10. And your median is midway, right? Since we have 10, it's the average of 5 and 6. So 10 divided by 20 divided by 2, which is 10. So we have a mean, median, mode, all of them as the same number. So mean, median, mode are all same, then it is a normal distribution. Did you get it? Please, this is important. What is a normal distribution? Santosh and Krishna.
Yes.
Okay, pretty simple. This is the easiest and the simplest way to remember. This is enough. There are a lot of things about normal distribution. Absolutely lot of things. There are many things which describe a normal distribution, but this is the simplest way to identify a normal distribution. If you remember this, that is enough. Okay, for a normal distribution, mean, median, mode all fall in the same. Let's write it down. This is normal. Okay. Okay, now Santosh and Krishna, give me an example of a normal distribution from your day-to-day life. What kind of data can fall into normal distribution? Day-to-day life, I mean, in your offices, salaries of the employees, or petrol prices, distances, anything you can find out and tell me, okay, this is a normal distribution. Okay, don't. I mean, so are you guys thinking, Santosh and Krishna?
Yes, sir. Our energy level, they working and it
Your energy
start
level.
from the morning to and evening up to that. It is
So is it normally distributed?
wake up is very lazy. After that, it is raising that up to such level, energy level.
Okay,
After that,
so
when you are doing
Krishna, what you're telling is your energy level in the morning is a little low and probably it will get high after some time and then it
and
will fall
increase,
down. So, but then, do you think if I calculate your energy levels, if I actually collect the data and then find out the mean, median, mode, will all be the same?
no, no, sorry,
No, right? No, it won't. So it is impossible. It is next to impossible for any data to follow normal distribution. It will not. Never ever. Any kind of data you take, it is definitely not normal distribution. Okay, it is impossible to have normal distribution unless and until our data is like this, what we have written here. It is not possible to have normal distribution. See, even if you consider this 10 as a score, as points, if you have 10 members in the class, all 10 should be scoring 10 out of 10. How likely is that? It is almost impossible, no? Even if one guy gets a 9.5 or a 9.9, then we are not a normal distribution. So it is highly impossible. Okay, Krishna, you were asking
So,
something.
but
yes, yes,
so but
I got it.
Ah,
but you are saying that we always assume that we are having normal distribution data.
yes. Why do we do it? Is because normal distribution makes our life very easy as a data scientist. There are some very good properties about normal distribution which are not available in other distributions. So we assume it to be normal distribution and we change the data, we transform the data a little to make it close to normal distribution, but we will never have a normal distribution. Okay. How do we do it? I mean, data transformation. Okay, I'll give you a simple example here. Okay. Hmm, perfect. So now again, I have say let's have the data. I again have data points. Mm, 1, 2, 3, 4, 5. I have 6 data points, and say this is very rough. I mean, okay, you don't literally take them. A rough figure. If this is 17,000, this is say 21,000, 32,000, 10,000, 19, and 21. Okay. If see for this is definitely not a normal distribution because my mean, median, more are like uh, okay. let's do it here in Excel. Now we can practically calculate everything and then check. Okay, data. We said 21, 25, 30. This is very rough data. Okay, if I calculate this, so what do we want? We want summary statistics, no? Okay, I'll go. Summary statistics is available in data. Go to data analysis. Descriptive statistics. You select your data. I want the output here. Statistics, is it okay? Okay, I have mean median mode here. See, my mean is 24. I don't even have a mode here. And my median is 23,500. Let's consider we have 23 also. So we will get a mode, okay? Are you guys following what I'm trying to do?
Yes.
Okay. Let's change the range. Okay, here we go. Okay, we have the same mean, median and mode as the same, but our average is changed 24. So what we do, we know this is not normally distributed. So we want to transform our data. So what I'll do is I'll take log of this data. Okay, and then I will calculate summary statistics on this data analysis. Okay, this is the data. We want the output to be here and say okay. Okay, now you see our mean is 4.37, our median is 4.36, and our mode is also 4.36. Earlier we had 1,000 difference between our mean and median, but now what is the difference which we have is 0.01. 0.01. So is it a lot of value? Yes, it is, but we have now transformed our original data to log values, and now we have a normal distribution here. Do you agree? Santosh and Krishna?
So we are getting confusing and transform data into log data. And why we need to convert into log data?
Perfect. Good question. So, see, I'm telling you our basic assumption. We always want to work with normally distributed data in data science. Every time we would love to, because it makes life very easy. Okay, it makes calculations easy. It makes us our understanding very easy. How does it make our understanding easy is something which we will learn through in the next few sessions. But for now, just think All we want to do is we want to have normally distributed data. Okay, you can write down this question for yourself for our future references to ask me why is it useful to have normally distributed. But for now, consider that any data, if normally distributed, then it is very easy to work with. Okay, fine. So this is the data which we have. Okay, so for example, I want to run linear regression on this. I'm telling you, if it is normally distributed, then it is easy to run a linear regression on this. Okay, but then I have checked my mean median mode, and then it is clearly not normally distributed because my mean median mode are not the same. So what do I do? Then I will transform my data. Okay, by transformation, I mean you can do any kind of a transformation. Here I have taken a log transformation of the data. So what I have did is I have taken log values for my original data. What I can do is I can take exponential values. I can divide it by 2. I can take half of it. See, even if I take half of it here, this one divided by 2. See, transformation does not mean you can do anything with your data. You don't have to ask anybody. You can multiply it by 3, divide it. You can take squares. You can do anything you want to do. Okay, and I have taken half. This is the half value. And if I do a data analysis, again, let's do calculations. Let's take the output here. You see, now our mean is 1200, our median is 1500. Earlier it was 1000 difference, now it is 500 difference. But this is also not good enough, no. By experience, I know log will be very useful, so that's why I did a log transformation directly. With log, I did a 4.37 and a 4.36, the difference is 0.01. So after you do the log transformation on this particular data, you do all your analysis. So for example, consider we are running a linear regression now. Why do we do a linear regression? I know I want to predict this X. What is the next value? Okay. Based on this, I want to run a linear regression and predict this X. Okay. So what I'm telling you guys is I will run my linear regression using this data, and then I will predict this as, say, for example, this has come out to be 4.45. So in order to get back to this, I know this is a log transformed variable. So what will I do is I'll take exponential of this variable. And I'm telling you, okay. EXP. One second. Okay. See, I absolutely don't remember how to convert a log variable into the normal exponential variable. So I just go ahead and Google it. Convert log 10 to a number in Excel. Uses XP function. Okay. Okay, I'll get back to you on this. Let's not do a time waste on that. How to get back to the original numbers. But did you get the concept? How do we
Sir,
convert? Yeah, please.
I mean, our data first we need to convert into the log data. After that, exponential data. Then
No, no.
why we are converting?
First, we will convert our data to be normally distributed. We can do any conversion. Log is just an example here. I can do a log conversion. I can divide my data by 2. I can multiply it by 2. I can take squares of my data. I will do everything. And then I will work on the transformed data. Okay.
Okay.
I will work on the transformed data. But when you predict, your values will also be in the transformed way, right? So here it will, what will it will give you some 4.54 or something. But then we actually want this number, no? We are not interested in this number. The actual number which we want is this. So what you will do is you will transform back the variable again in order to get this variable.
So, is there any documents related
No,
to
there is no
understand?
document. This is all only by practice. You will have to practice it, think through it, and then only you will know. There is no document available, and I'm sure there is no, I mean, it is not even explained anywhere as to why you do it, how you do it. The idea is, what you will have to remember is your data, you would like to have your data normally distributed, and how can you have a normal distribution is by transforming the data. You remember this point. Then whenever you are really working on some data, you will have to remember, okay, my data is normal. You check, this is first checkpoint to check if your data is normally distributed or not. Then you'll see, okay, my data is not normally distributed, but I would like to have a normally distributed data. So how can I convert is, you can convert your normal data into normal distribution by doing transformations on the data. What transformations you will do? You can do a log transformation, you can take squares, you can do division, you can do multiplication, you can do anything. Anything is a transformation. You multiply it by 3, you multiply it by 10, you divide it by 100. Whatever you feel like, you just do it, and then you do whatever work you want to do, and then you see the output. If you're okay with the output, go ahead and implement it. If you're not okay, then try another transformation. It is all trial and error. There is nowhere anything written that for this kind of data we'll have to do this transformation. But most of the times, 90% of the times, your log transformation works pretty good. That I can assure you. Yeah, Krishna and
Yeah. Okay.
Santosh.
I mean, main thing is transformation data. If it is not possible in the normal distribution of our data, then we need to convert it to nearby to the normal distribution data. Right?
Perfect. That's absolutely correct. And how do you convert it?
By using, I mean, it is some of the formulas log or x square or division or multiplication.
Perfect. Absolutely right. You're spot on. You're absolutely spot on.
Sir, every time we have to do this process.
You don't have to do every time. You don't have to do every time. But usually what we will do is we will do our analysis on this data only, assuming that it is normal. We will not even check. Okay, we will do our analysis. After we have
Okay.
completed our analysis, and then we have come out with the output. Okay, so for example, this is the let's say this is stock market data. Okay, and this is in the month of January, and in February I'm telling the Sensex, I wanted the Sensex numbers in February. Okay, now what will be, so I am using some analysis to predict what could be the Sensex be in February. See, I worked with this data, and then I have predicted that this will be 25,000. Okay, I have predicted this, and now we are in January. On March 1st, actually now on March 1st, I know what the actual value of Sensex is in February, no? Yes. And then I found out that the actual value was 24,450. Okay. Now, what you will do is, Santosh has actually asked me to predict the February value. Okay. Santosh asked me. Okay. Then I took this data. Then I have predicted this for the February value. And on March 1st, I'm going to Santosh and I'm telling you, okay, Santosh, this is the actual number. Since February is now over, this is the actual number, and this was the number which was predicted. What do you say? So, so the difference is 550, right? So Santosh will say, okay, Arun, you did a good job. 550 was good enough for me. This difference is okay. Since you were able to predict that it will be 25,000, I was able to make some 20,000 from the stock market in the month of February. So I'm happy. That is what Santosh is telling. So what would I do? I will do nothing. No. What will I do? Using the same technique, I will predict for March again. Okay, I will predict for March, and then I will say in March it will be 26,000. That is one way. Okay, but now there is another way. I said, okay, Santosh, I did the prediction. It came out to be 25,000. But on March 1st, I'm going to Santosh and I'm telling you 20 the actual value is 24,450. But now Santosh says, hey Arun, this prediction of yours was not very helpful for me. I actually lost money because of your prediction. So this kind of an error is not okay for me. That is what is Santosh telling. So what will I do? I will have to improve my model now because Santosh is not happy with the error percentage. So what will I do? Now I will try and see what I can do. Then I will check if this is normally distributed or not. Then I will see, okay, let me try a different model. I will transform these variables and then try to predict. Are you getting where I'm going? So it is always about generating a model, rolling out the results, and going and asking your stakeholder, are you okay with the error percentage? Are you okay with the accuracy? If they are okay, why do you have to put in a lot of effort to improve the model? You don't have to. If they are not happy, then that is when you will think, okay, let me transform some variables and see if I can have a higher accuracy and so on and so forth. Are you getting my point?
Sir.
So, so it is all practice, Krishna and Santosh. There is no hard and fast way. I cannot give you a checklist. Okay, these are the 10 points which you will have to do one after other for doing a project. No, there is nothing of that kind in data science. Data science is always about trial and error. The amount of data, the amount of time you spend with the data, that is where you will get more interesting ideas. Okay. I know it's a
Yeah.
little heavy, but these things are there. I mean, it's always about trial and error. Data science is all about always about trial and error. You never know what is the first model you want to implement. Will it work? Will it not work? In my experience, there was one data set which probably I worked on data on that particular data for more than 4 months, and I have built uh, 13 or 14 different models for that particular data. So it is like that. And you know what? The most interesting part, I don't want to confuse you, but I want you to think. See, this is model one. Say I'm using this data as is. Okay. Now this is my model two, where I am using log transformation. Using log transformation, also I am predicting the data. So using log transformation, for example, I have predicted the value to be 24. Okay. Are you getting my point? Using land log and using the same values, I predicted 25. Using the model 2, which is a log transformation, I predicted 24. You know what? I will actually go ahead and tell Santosh. Okay, Santosh, I will actually tell average of these two models. I will give this value to Santosh. Now, if I have given this value and my actual value is 24,450 and I'm predicting 24,500, my error is what? 50, no? My earlier error was 550, but now my error is 50, no? So my model 3, which actually does a great job, is the average of my model 1 and my model 2. So how did I come up with this kind of a model? Only by practicing only by trial and error, yes, I will come out with these kinds of ideas. So this is where, in my first demo, when I told you you'll have to be very creative, this is where the creativity comes out. No, see, all you will have to do is try different things. You build different models. You try and take averages of these some models. You sometimes a single model works well. Sometimes you'll have to build three, four models and take average of those models, something of that kind. Is it confusing or is it pretty clear for you? It should be either of these two, or you need some time to absorb whatever we are going through today.
And sir, could you provide the material related to what you're saying, but to
There
understand
is no material,
what
Krishna. There is no material. All you'll have to do is practice. You will not find
practice?
materials for this. This is all whatever I am teaching you, whatever I am telling to you today is all based on my experience. Nobody has told me that you will have to try something of this kind. So my suggestion would be you will have to take some data. You will have to take some data. See, I will give you some raw data. I will give you some raw data and then I will give you some exercises. Okay, Krishna, Santosh, do this particular linear regression. And then I will give you, I will also run my own regression on that. And then we can compare our errors. So your error, if you have hit an error percentage, and then I'll tell you, hey Krishna, my model gives me a lesser error. So there is still a better model. Then I will give you, then you try for something else. Are you getting my point? So I have given you some data and then we will take some 2 days time to build some models on that. Okay, then we will form a table, then we will form a table of this kind where we say error and then we will write an error percentage. So how do we calculate error? It is simple, no? Uh, okay, we'll see how to calculate errors. For example, let's take the 10 percentage error for you. And then if for me it is 2 percentage, then I'll tell you, Krishnam, I have a model which has a lower error percentage than what yours is. Then you can go ahead and try building one more model, model two, model three, take averages, whatever you want to do. Then we will take 2 3 days time. Again, we will compare our errors. So that is a way of learning. There is no material on this. I can see. Here I have given you an example of where we are taking an average, but there are examples where uh, you take average of four models. I cannot give you an example for that. No, it's all about learning by practice. So we can practice, but absolutely you will have to elaborate on the way you think rather than trying to depend on a specific way of doing it. You're trying to understand what I'm telling you? We can practice. I can give you a data set and we can practice on that, but as such, material wouldn't be available because this is all by experience. You learn by experience, you learn by trial and error. Since this is an initial class, this all looks very complicated, but this is not as complicated as you guys are thinking it to be.
Okay.
We haven't even gone into building a model. We are talking about a very larger overall phenomena. Krishna and Santosh, silence.
Okay, sir. Understood.
Okay. So let's stop here for today. I will send the PPTs and the Excel sheet right away to the institute. They will distribute it back to you. So please practice. Please practice R also. Since I will also share the raw data file for R and I will also share the R codes also. Uh, Read a little about normal distribution if you have time. Uh, if you don't find time, if you think it's pretty confusing, don't bother about it at all. Just remember, if mean, median, mode are the same, then it's a normal distribution. Else it is not. And most of the times, our basic assumption would be that any data would be normally distributed.
and then we will do all the work on that. If the error percentage is too high, that is when we think about transformation. We just simply don't go ahead and transform things. Okay, our assumption is that it will be a normal distribution. Okay.
Okay.
Anything else? Any questions? Anything you want me to report from today's class?
No.
Santosh, about the video, yes, you will get it. No problem at all. So let's call it a day. Have a good day ahead. Have a happy Monday.
Okay. Yeah. Thanks.
Thank
Bye.
you.